A dead electric car battery looks like a heavy black slab. Useless. Finished. Something you'd pay someone to haul away. But inside that slab there's lithium, nickel, cobalt, manganese, copper, aluminum, and graphite. Every one of those materials is something car manufacturers are currently fighting over on the global market. And when a recycling plant shreds that battery and separates what's inside, what comes out is a fine dark gray powder called black mass. That powder is worth more per ton than most of the rock pulled from an actual mine. That fact alone tells you something important. But it doesn't tell you the real story. The real story is that China builds more batteries, more solar panels, more phones, more buildings, more clothes, and more infrastructure than any country on Earth. It's been doing it at a speed nobody in history has matched. And now, all of it is starting to age at the same time. The batteries installed 5 years ago are dying. The solar panels bolted to rooftops a decade ago are degrading. The apartment blocks thrown up during the construction boom are being demolished. The phones in everyone's drawers are piling up. The clothes worn once and discarded are stacking into mountains. And the food waste from 1.4 billion people is rotting faster than anyone can process it. China doesn't have a waste problem. China has a wave. And every piece of it is arriving at the same time because everything was built at the same time. The construction boom, the solar boom, the EV boom, the smartphone boom. All of it happened in the same 20-year window. And now all of it is aging in the same 20-year window. What China decided to do with that wave is the part nobody outside the country is paying attention to. Because it didn't treat this as a crisis to manage. It treated it as a raw material supply that happens to arrive in the wrong shape. Garbage is just a resource that hasn't been sorted yet. That's not a slogan on a poster. That's an industrial policy backed by trillions of yuan in committed infrastructure spending. That number is public. It's in government planning documents. And everything in this video shows you where it comes from. Start with the batteries, because they're the easiest to understand. A battery pack pulled from a scrapped electric car still contains every expensive material that went into building it. The lithium didn't evaporate. The cobalt didn't disappear. They're sitting right there in a form that somebody already refined and assembled. The recycler's job is to reverse the assembly. First, the remaining charge gets safely drained. This part matters. A partially charged lithium battery that gets crushed wrong is a fire. Then the pack gets checked. If it can still hold a useful charge, it might get a second life storing solar power in a warehouse. That delays the recycling. It doesn't replace it. That battery is still coming back eventually. For the ones that are truly done, the process is straightforward. Dismantle into modules. Shred. Mechanically separate the metals, plastics, and casing. What remains is that dark powder. Black mass. The concentrated electrode material holding the nickel, cobalt, manganese, and lithium. Chemical or thermal processing pulls those apart into battery-grade compounds. Those compounds go straight back to a cathode factory. The loop closes. China currently controls roughly 70% of global battery recycling capacity. By some estimates, close to 80% of the shredding infrastructure and nearly 90% of the refining stage. This isn't a country experimenting. This is a country that owns the machinery. And in 2025, China did something that changed the international game entirely. It created a national quality standard for black mass. And from August of that year, any black mass meeting that standard stopped being classified as solid waste. It could be imported freely. While Europe was tightening regulations and treating the same material as hazardous waste, China was writing rules that let it flow in from everywhere. The industry doesn't put this on the brochure. China's licensed, regulated battery recyclers have been running at roughly 20 to 30% of their capacity. Not because batteries don't exist. Because unlicensed backyard workshops with zero compliance costs can outbid them for the raw material. The country built the factories. The batteries went somewhere else. The machine is real. The machine is enormous. And the machine is half empty. Batteries at least contain enough value to justify all that expensive equipment. The next problem is harder precisely because the material is worth almost nothing. When a building comes down in China, what's left is concrete, rebar, steel, brick, asphalt, glass, timber, gypsum, soil, stone, and a lot of mixed debris nobody can identify. By sheer tonnage, construction waste is the biggest waste stream in the country. It's not even close. In 2020, China generated roughly 2.6 billion tons of it. Billion. With AB. The recycling process is brutally simple. Crush everything. Pull out metals by hand or magnet. Run the rubble through screens to sort by size. Blow out the light contamination with air. What comes out is recycled aggregate for road bases, fill material, and some concrete applications. The steel goes back into the metal system where it's always gone, because steel has been worth money forever. No exotic chemistry. No black mass, just crushing. And yet only about 12% of that 2.6 billion tons got recycled. The overall utilization rate sits under 40%. For comparison, the United States recovers roughly 75% of its construction waste and generates far less of it. The reason is embarrassingly simple. Crushed aggregate is cheap. Dumping in a landfill is cheaper when the fees are low. And for a long time, fees were low. The technology was never the bottleneck. The economics were. You can crush anything. Getting back something an engineer will actually sign off on for structural use is a completely different problem. Contaminated rubble from an uncontrolled demolition site is not the same material as clean separated waste from a managed one. Construction waste hides its value in enormous quantities. The next stream hides it in pieces smaller than a grain of rice. A ton of, or from a gold mine, might contain a few grams of gold. A ton of circuit boards can contain many times more. The richest gold deposit near any Chinese city isn't underground. It's in a drawer, in a warehouse, in a pile of dead phones. That's what urban mining means. It's not a metaphor. It's a statement about concentration. Electronic waste includes phones, computers, televisions, fridges, washing machines, servers, cables, and screens. Inside all of it sits copper, aluminum, steel, gold, silver, palladium, and depending on the device, specialty metals that are genuinely rare. The process starts with collection and categorization. Batteries and hazardous components come out first, always. Then the device gets dismantled by hand or shredded by machine. Magnets grab the ferrous metals. Eddy current separators catch the non-ferrous ones. Optical and density sorting splits the rest. Then smelting or hydrometallurgy extracts the final metals. There's always something left over that needs treatment or disposal. No process recovers everything. China has been formalizing this aggressively. Between 2024 and 2025, roughly 53 million used appliances and phones entered standardized dismantling channels. That number grew at about 12% per year. A single licensed plant in Fujian processes over 2,000 discarded appliances every day. A fridge enters one end of the line. Separated plastic, metal, and foam exit the other, each routed to its own recovery path. The concentration of valuable metals in electronic waste is so much higher than in mined, or that the economics are obvious. The challenge isn't proving it works. It's competing with informal recyclers who strip the valuable parts and dump the rest. But the hardest material on this entire list isn't batteries or buildings or electronics. It's something you're probably wearing right now. Pick up a shirt. If the label says 100% cotton or 100% polyester, that's a solvable problem. One material, one process. But if it says 60% cotton, 35% polyester, 5% elastane, and it has a printed graphic, a coating, buttons, a zip, and dye, you're holding something that essentially no process on Earth can turn back into an equivalent new shirt. That's textile recycling in one sentence. Purity is everything. Modern clothes are engineered to be impure. You can resell or repair the garment. That's reuse, and it's the best outcome. You can shred it into insulation or stuffing. That's recycling, but it's a one-way trip downward. The shirt never comes back. Or you can chemically break down the synthetic fibers and rebuild them into fresh material. That's the route that actually matters. A company in Zhejiang called Zhejiang New Materials is producing recycled DMT, one of polyester's chemical building blocks, at purity up to 99.9%. Their capacity is 50,000 tons a year now, with output projected to reach 500,000 tons by 2030. Set that against the pile. China produced around 22 million tons of textile waste in 2020 and recycled roughly 20%. The government's most ambitious target for 2030 is 30%. That's an honest admission. Even the official plan assumes 7 out of 10 discarded garments are never coming back. Clothing can sit in a warehouse for a decade without changing. But before we get to what destroys itself in hours, there's a material that changed the entire global recycling system with a single policy decision. For decades, China was the world's recycling bin. Since 1992, it imported roughly 106 million tons of plastic waste, close to half of everything traded globally. Europe and North America would put their yogurt pots in a bin, feel good about it, and ship them across an ocean to Chinese factories that use them as cheap raw material. Then on January 1st, 2018, a policy called National Sword landed. China banned 24 categories of imported waste and dropped the contamination limit so low it functioned as a total ban. Plastic imports fell by 99% overnight. Recycling programs across the United States were canceled. Britain burned more. Southeast Asian countries got buried in bales they never asked for. The world discovered that its recycling system had been one country, and that country had just closed the door. The ban forced something nobody expected. China had to build a domestic collection and sorting system from scratch because the factories still needed feedstock and it wasn't arriving by ship anymore. The hard part of plastic isn't the clean bottles. Those are easy. One polymer, no contamination, sort it, shred it, melt it, reform it. The hard part is everything else. Multi-layer packaging engineered so its layers never separate. Films bonded to foil bonded to adhesive. Black plastic that optical sorters physically cannot detect. For that, you need chemical recycling, pyrolysis, depolymerization, processes that break plastic down to molecular building blocks and rebuild from there. These processes work. They also use enormous amounts of energy and expensive equipment. And some of what comes out is fuel, not new plastic. That's not nothing. It's also not the circular loop the brochures promise. Now the material that starts destroying itself within hours. In a city like Shanghai, wet food waste has historically been around 60% of household garbage by weight. And it's the single worst thing you can mix with everything else. It's heavy. It's wet. It contaminates every dry recyclable it touches. Food waste doesn't just have its own problem. It breaks the other solutions. But separate it out and the physics gets friendly. Anaerobic digestion puts organic waste into a sealed tank with no oxygen. Microorganisms break it down. That produces biogas, mostly methane, which gets cleaned and burned for electricity or upgraded into vehicle fuel. What's left can be processed toward fertilizer or soil amendment. Can be. Not always is. Digestate carries pathogens and heavy metals. Chinese kitchen waste is salty, and salty compost is useless for farming. On July 1st, 2019, Shanghai did something that seemed insane at the time. It made household waste sorting mandatory for all 24 million residents. For bins, household food waste, recyclables, hazardous, residual. Individuals faced fines up to 200 yuan for getting it wrong. Companies up to 50,000. People hated it. It trended on Weibo as a joke about residents being driven insane by garbage rules. And then it worked. Sorted food waste collection went from roughly 4,000 tons per day to a stable 9 to 10,000. More than double. The separated food waste came out at 99.5% purity, which is the number that actually matters because a digester full of plastic bags is a broken digester. Recyclable collection rose sharply. Hazardous waste collection went up by a factor of 10, and residual waste dropped by 20%. And this is where everything connects. Because the wet food waste was removed, the remaining garbage had nearly double the energy content, which made it dramatically better fuel for the waste-to-energy plants. And those plants are operating at a scale that's hard to wrap your head around. By the end of 2024, China had over 1,100 waste incineration facilities running. Total capacity exceeded 1.1 million tons per day. They produced roughly 145 billion kilowatt-hours of electricity. Research published in Nature Communications found these plants supplied up to 7% of China's residential electricity consumption. Incineration became the dominant method. Over 78% of urban household waste now goes to incineration. Sanitary landfill dropped to around 13%. If your image of Chinese waste management is cities ringed by open dumps, that picture is years out of date. Now step back from all of it. Batteries, buildings, electronics, textiles, food, plastics, solar panels aging on rooftops by the millions. Every one of these streams exists because China built more than anyone else, faster than anyone else, for longer than anyone else. And now every one of those products is reaching the end of its first life at roughly the same time. The government looked at this incoming wave and didn't see garbage. It saw a domestic supply of raw materials that doesn't require a mine, doesn't cross an ocean, and doesn't depend on any other country's willingness to sell. Lithium from dead batteries instead of African mines. Copper from old phones instead of Chilean exports. Steel from demolished buildings instead of Australian ore. Glass from retired solar panels instead of fresh silica. This is the same logic we saw in the energy video. Reduce dependency. Localize supply. Turn vulnerability into infrastructure. And there's one more stream that nobody wants to talk about because it spoils a feel-good story. Solar panels. A solar panel is a climate solution right up until the day it becomes 20 kilograms of laminated composite that nobody has a plan for. Inside it there's glass, aluminum frame, copper wiring, silicon cells, encapsulating polymer, and a small amount of silver. By weight, it's boring. 2/3 glass. But look at the value instead of the weight, and the picture flips. The silver in the cells accounts for over 60% of the panel's total economic value. And it's the hardest part to reach because everything in that panel was laminated together specifically so that 30 years of rain, hail, frost, and UV couldn't get in. The recycler is trying to undo at a profit the exact thing engineers spent decades perfecting. China's photovoltaic industry expects retired panels to hit around 18 gigawatts by 2030. By 2040, cumulative waste could reach 20 million tons. Not because the panels failed, because China installed a staggering number of them, and they're all aging on the same schedule. Right now, most panel recycling recovers the aluminum frame and the glass. The silver, the part that's actually worth the money, stays trapped. The circular economy isn't an environmental slogan here. It's industrial strategy with a price tag in the trillions. And the honest picture includes the failures. Battery recyclers running at a quarter capacity because black market operators undercut them. Construction waste recovery stuck at 12% because landfill fees are too low. Textile recycling capped at 30% even in the best-case government plan. Food waste digesters struggling with salt content. Solar panel recycling that mostly recovers the frame and the glass, while the silver, the most valuable part, stays locked in layers that were engineered to never come apart. None of this is solved. All of it is underway. The difference between China's approach and most other countries isn't technology. It's the decision to treat waste as an industrial input at national scale, fund the infrastructure, write the regulations, and accept that the first decade will be messy and incomplete. The wave is arriving whether anyone is ready or not. 20 years of the fastest industrialization in human history is now producing 20 years of the fastest waste accumulation in human history. China decided to build the machine before the wave hits full force. Whether that machine works as promised or drowns in its own contradictions is the question the next 5 years will answer. Which part of this changed how you think about the thing you threw away this morning? The battery powder worth more than mined, or the construction rubble that nobody can make money crushing? Or the Shanghai food waste law that outperformed every piece of technology in this entire video? Tell me in the comments. Subscribe to Tech Unwired for more. No hype, no fluff, just tech that actually matters. The next video follows directly from this one.